Okay, so now we're taking these curves and mathematicians are figuring out how to represent them with variables. So we're going to be moving these parabolas around on a graph with an equation that actually represents parabolas. So let's pretend we took the flashlight light and put it on a grid. So x and y coordinates. Now, what can we think about in terms of the equation? What's our equation going to look like if we're looking at something like this? So if we notice our y values are always positive. Doesn't matter if x is negative, our y values are always positive. Also, this graph is symmetrical. So if we took that center right there and we folded it over, it would be the same on both sides. So whatever equation we choose for our parabolas, it has to make sure it has those properties about it. So when we're looking at our equation, we want to think about what's happening here. So if we look over at 2, we can see we're all the way up to 4 on both sides. So we're squaring 2. Let's look at what this equation can look like. So we have our x's and y's. And we're going to look at an equation that's different than our linear equation. We're going to square x, so y equals x squared. Let's look at some of our values. Well, when x equals 0, 0 squared is just 0, so that's 0. When x equals 1, 1 squared is 1. When x is negative 1 squared is also 1. 2 squared is 4. If we put a negative 2 in there, negative 2 squared is also 4. Notice I'm getting positive values. We can do the same thing with our 3 and negative 3. So this is going to give us, you can see it's symmetrical on both sides there. So when it's 2, it's 4, and when it's negative 2, it's 4. I'm going to use this graphing program to go ahead and graph y equals x squared. Now if I plotted all those points, they would be on that graph. Now we can change that algebraic graph by adding a few coefficients or some numbers in there. Let's just go ahead and take a look at another example and we'll see what happens. So say we have the equation y equals x squared plus 3. Well, here's our x squared, so it's still going to be going up like that. It's still going to be positive, but every time I have an x squared, I'm going to add 3. So if I have a 0 in here, 0 squared plus 3, that's going to give me a 3. So instead of starting at 0, 0, I've started at 0, 3. 1 squared plus 3, I'm adding 3. So on my y-axis, I'm going up 3 each time. Negative 1, I also get a 4. Let's try 2. I plug in a 2. 2 squared is 4. 4 plus 3 is 7. And the same thing happens when I plug in a negative 2. So negative 2 squared is also 4. Plus 3, I'm going up 3, and that's 7. So I predict that my graph is going to move up 3 when I type in y equals x squared plus 3. And there it is. So you can see it moved up 3. Let's try another one. What do you think will happen if I do y equals x squared minus 4? So what is that original graph y equals x squared going to do with that minus 4? Well, let's plug in a few values. I put a 0 in. 0 squared minus 4 is negative 4. Let's plug in another value, 1. 1 squared minus 4, so that's 4 less than my value for 1 for y equals x squared, and that gives me a negative 3. Negative 1, and I also get a negative 3. Notice I have some negative values that I didn't have before because I've moved this parabola down. Put in a 2. 2 squared is 4, and I get a 0. So 4 minus 4 is 0. The same thing happens with negative 2. So notice I still have my symmetry. 1, it equals negative 3. Negative 1 is negative 3, but it's moved everything down negative 4. Let's go ahead and check this on the graphing calculator. This is a great graphing calculator, by the way. It's a Desmos. So if you want to look that up online, you can use this graphing calculator too. And there it is. Our same parabola moved it down 4. Now the parabola sides go on forever. That's important to understand. It looks like it's a bigger parabola, but it's not. It's just moved down more and it keeps getting wider and wider. Now in Khan, sometimes he likes to write it like this, y plus 4 equals x squared. So if it's in that form, you can just change it back to y equals x squared minus 4. I think that that's a better form. And we'll look at that again as we look at another example. So let's see if we can make this parabola skinnier or fatter. If we want it to rise faster, if we want the y values to go up much faster for my x values. So to do that, we're going to multiply the x squared by a coefficient, 2 times x squared. That way my y values will be bigger when my x values stayed the same as I originally put in. So if I put in a 0, I still get a 0 out for y, but watch what happens when I put in a negative 1. Negative 1 squared is 1 times 2, so my y has gone up faster. Now I'm going to put in a 1. If I put in a 1, I have 1 squared. 1 squared times 2 is also 2. And let's try negative 2. I put in a negative 2. Negative 2 squared is 4 times 2 is 8. So I'm really going up fast here. And then if I plug in a 2 for my x, 2 squared is 4 times 2 is 8. I also have my 8. Now watch what happens when I put a 3 in. Negative 3 squared, so I'm putting a negative 3 in, is 9 times 2 is 18. I'm all the way up to 18. So let's go ahead and graph this and compare it to our original parabola. We didn't move it up at all, we just made it steeper. So let's graph it using our Desmos Graphing calculator. And when we type it in, it likes to start graphing whatever I type in. So now I've got the final thing. You saw the 2x there for a little bit. And see, it's skinnier. It's skinnier than the other one. The y values changed more rapidly than my x values. So what do you think would happen then if we looked at y equals 10x squared? So if we had 10x squared, the values we put in for x are going to be multiplied by 10. So they're going to go up really fast. That should be a pretty skinny parabola. So let's take a look at that. And y equals 10x. You can see that on there. It's a very skinny parabola. The y values are going up really fast. So what if we wanted to do a parabola that was fatter? So our original one, y equals x squared, how would we do that? How would we make y not go up as quickly? So we don't want y to go up fast. And when we put in x's for our x squared, we have to do something to them to make them less than. And we've got to think about multiplying. I guess we could do a negative, but that's not going to change how quickly it happens. So let's look at what we can do. So if we have an x squared, and say we put a 1 in there, so we have a 1 squared, and we want to multiply it by something that's going to make it less than 1. And we can use fractions to do this. So that will give us a 1/2. Oops, I forgot the x squared there. Let me fix that. That's a 0, 0. Here we go. Okay, so we have, when we put in a 1, we have a 1 squared, and then we're multiplying by a half. So we're making y rise less. Okay, so we're changing how fast y is going up just by multiplying by 1/2. And you can see that instead of our 4 like our original, we end up with a 2. So let's go ahead and graph this and see if it makes a wider parabola. So y equals 1/2 times x squared. Okay, so graph the line first before I got the squared in there. And you can see that that red parabola is wider than my blue parabola. Now if I wanted to make it even wider, I could try this. Instead of 1/2, I could multiply it by 1/10. So take an even smaller fraction of those x squared. If I put in a 1 there, my answer for y would be 1/10. Let's take a look at what that looks like. Oh, that is one wide parabola. That actually looks a lot like our satellite dish. Okay, so now let's take a look at wanting an upside-down parabola. So we've got kind of a smiley parabola here. It looks pretty happy. It's like a big smile. And we want the parabola to look like it's facing down, like when we had the McDonald's sign or the rainbow. So in order to do that, we need our y values to be negative. Well, so far, we've only had positive y values. So we need to somehow figure out how to get negative y values. So when we're looking at our equation, y equals x squared, we want to make sure we come out with negative values.
Upside down, turn that smile. upside down, turn that smile, upside down.
So it's not very often you want to be negative, but for this case, for our parabola, we want our y values to be negative. So if we look at just y equals x, we know that all of our y values are going to be positive because we're squaring those x values. So -1 is going to give me a +1 for our y values. The same is true with -2. We square it, it gives us a positive. So we want all of those to be negative. Now in order to do that, we're going to have to multiply this by a negative. So if we just did like a -1, we would have -x². Now that's different, and important to note that that is different than -x, the whole quantity, squared. Because if you square the negative, you're going to get a positive. But that's not what it says in this case. It says we're going to take x² and we're going to take the opposite of it because it doesn't have that x in parentheses. And so if we do that, we square x and then take the negative of it, all of these will be negative values. So it'll essentially flip that parabola down. Now let's go ahead and take a look at what that would look like. And there it is. Y equals -x². So if you ever have a frown, you want to turn that parabola upside down. So that negative parabola looks like a frown, not like a smile. So let's see if you can come up with in your mind what an equation would look like if we had a skinny parabola and it was opening facing down. So we want a skinny parabola opening facing down, or frown. And remember, when we want it skinny, that means our y values have to change faster than our original. So it's going to look something like this. So see if you can come up with an equation you think might work. And it doesn't have to be an exact equation. You just want a skinny, downward-facing parabola. So we know it's going to be negative, and then you get to choose kind of a large number. I chose 20. So -20x². And any number that was bigger than 1 would really count as a skinny parabola. So let's go ahead and graph this and see what it looks like. So see that purple one? A skinny, downward facing. So if x were equal 1 right there, 1 squared times -20, y would be -20 at x equals 1. All right, so now we've talked about moving the parabolas up and down. Let's talk about what happens when we try to move the parabola sideways. And we're going to do that by putting a number inside. We're going to subtract 2 and we're going to put it inside the squared part. Now, you might think that since it's a -2, we're moving the parabola to the left 2 in the negative direction. But let's see what happens as we put in numbers. So right now, if we look at our parabola, the vertex is at 0, 0 for y equals x². Let's see where the vertex moves as we put in numbers. So if we're moving left and right, our y is going to stay 0 of our vertex, but the x part is going to move. So if we put in a value for x, let's say 2. And then let's see what y equals when we put in a 2 for x. So 2 minus 2 squared, 2 minus 2 is 0, so y is equal to 0. So our vertex moved to 2, 0, so it moved to the right. So you can think about whatever goes in that squared parentheses, whatever you're squaring, that x minus 2, whatever would make that 0, that's the direction you're moving horizontally. So let's try another value in here. Let's try 4. So if we put in a 4, we're going to get 4 minus 2 squared, and y is equal to 2 squared, or 4. So when we moved to the left 2, we got a 4 out. Well, now let's try 0. So that's the same distance from the 2 as the 4 was from the 2. So we put in 0 minus 2 squared, which is just -2 squared, which is also 4. So we're still seeing the symmetry in here. It's just centered around 2, 0 instead of 0, 0. So let's go ahead and graph this, and we'll use our graphing calculator from Desmos and type that in. Y equals x minus 2 squared. Now see, it moved it. It's that orange parabola over there. Moved it over 2 on the x-axis. So what's going to happen if we have something that looks like this? Y equals x plus 6 squared. Well, we're going to look at what makes that 0 because that's where our vertex is going to move to. Looking at our equation for that parabola, we can see that if we put a negative 6 in there for x, we are going to get negative 6 plus 6, which gives us a 0. And when we square it, we get out a 0. So that's my y value. And so my parabola, that vertex, is being moved over to negative 6. Now let's try 2 more values in relation to that negative 6. Let's go negative 2 past that, so on the x-axis, and we'll see what we get for y. So y is equal to negative 8 instead of x plus 6 squared. So negative 8 plus 6 is negative 2 squared. And then we have y is equal to 4. Are you seeing the pattern here with our moving of the vertex? Let's try negative 4. That's 2 in the positive direction. So we have negative 4 plus 6 squared. And negative 4 plus 6 is 2. 2 squared is 4. So we have that symmetry going on. So if we look at negative 6 and we go 2 in either direction, we can see that we get the same y value. Now let's go ahead and graph this so you can see a visual of this, just moving that parabola to the left, 6. Okay, so let's try combining a few of the things we've learned. Let's say we have y equals a negative x plus 5 squared. Okay, so we need to remember that that negative causes our parabola to open downward, or to frown as I like to think of it. The x plus 5 squared, that is how we're going to move our vertex in the x direction, and whatever makes that inside 0. So we're going to move it to the left 5 because negative 5 makes that 0. Plug in a negative 5 there, you get 0 squared. Negative 0, of course, is just 0. And so that parabola, our y equals x squared, faces down and it moves to the left 5. So let's go ahead and graph it and see our visual. Look, it's graphing negative x there, now negative x plus 5. Now we squared it. Okay, so now it's a parabola. And notice it moved to the left 5 and it's facing down. So its vertex is at negative 5, 0. And that's what's great about this form, is you can really tell what the vertex is. All right, let's try another one. Y equals 10 times x minus 2 squared plus 7. Okay, so this uses lots of things. So that 10 right there tells us that that's going to be a skinny parabola. That 10 is making y change really fast. And this x minus 2 in here tells us that the parabola moves right 2, because 2 would make that a 0 there. And that 7, up 7. So let's go ahead and graph it and see if it does just that. We expect a skinny parabola that goes to the right 2 and up 7. And that's exactly what it does. We've got a skinny parabola here. The vertex is at 2, 7. And by putting it in this form, we can look at it and just see the vertex, what the vertex is going to be. Now, when you're doing con, he has it written a little bit differently. It's actually not the way I like to write it. I like to write it like this, so it's pretty easy to see the vertex, but this way is not bad. So we have a y minus 7 equals 10 times x minus 2 squared. And so we have that 7, that plus 7 on the other side. And this is the way con does when he's asking you to graph parabolas. And that's okay. If we added a 7 to both sides, it would be just like our regular form there. So just kind of keep that in mind when you're trying to solve those parabola problems. You can just put it back into this form, and this form is called a vertex form. It's very handy because it shows you the vertex of that parabola, which really is half the battle in graphing those parabolas. All right, I think you're ready. Let's go ahead and look at Con and see how he does things. So right here, you're going to be able to change the values just by putting the plus and minus. And unfortunately, you can't do fractional values. You're trying to make your blue parabola look like the orange parabola. And you can do that just by clicking on these buttons, and it moves it around. So if you put a 0 there, it makes a line. If you go down negative, if you push this negative down there, you go negative, and this parabola is pretty skinny. So I'm guessing like a -3. And now I need to move it over. I need to move it to the right one. So by doing that, I can go ahead and what I need to do, if I push this plus button, it's going to go the wrong way. So if I push the minus button, I add a -1 here, and 1 is what makes that 0, so that's what moved it to the right one. And then I want to move it up. Now remember, I want it to go up 1, so a +1 would be on the other side, but if I put it on that side, I'm going to have to subtract a 1 or add a -1 to both sides, so that's going to have to be -1. And then I can go ahead and check my answer. Let's just look at one more. Here I have an equation of parabola, and it looks like it's moved down and to the left. So if I make it a little skinnier, I see that's probably too skinny. Just having a 1 in front of that x minus thing. And when you write a regular equation, you don't normally put that 1 in there. It's just implied. And now I need to move it. I push the positive because I want that to be a +2 in order to move it to the left. And then I can go ahead and move it down 5. And I have that +5 there because it was a -5 on the other side. All right. So you kind of get an idea how to do this. So it's time for you to try this on your own.